And let's start. All right, today's exercise is a follow-up from last session. Last session, you looked at areas of a circle, and we recapped. This is the formula for the year 9s, okay? This bit here is technically the year 8, okay? And then we're just adding this bit on, which is the year 9s component, and that is for partial circles. Okay, so depending on which part of how much of the circle they're going to give to you, that's what the angle represents. So an example would be that if I rotated, so 0 always starts here. If I rotated around the circle, let's say I went to 180, no, that's more than 180. That's about 200 degrees. Okay, so if I rotated from here, I rotated 200 degrees. What is the area of that shape? So you can see that that's not a full circle, it's a part of a circle. So that area, since I've rotated 200 degrees out of the 360, that's why the formula there has an angle depending on how much you're rotating out of the 360. Why was it the year 8 version doesn't have it? Because year 8s usually do full circles. So if it's a full circle, it's 360 out of 360, which is 1. That's why it doesn't feel like you have that extra theatre over 360. Okay? But today's lesson, we are going to do questions that are partial circles. That's why we're going to make sure you know how to use that formula there. Okay? All right. Write in your notes. Partial circles are also known as sectors. Okay? So when we say a sector, we specifically talk about circles, and it just means portions of a circle. The thing about a circle is that when you cut it up and you portion it, say I do it like this. Actually, I'll go all the way like this. Pac-Man. There is 2 types of sectors or areas. You see, you've got the smaller region, and then you have the bigger region. This is called your major sector. This is called your minor sector. Okay, so write that in. When we talk about sectors, it just means area of a partial circle, but there's 2 parts there. Are you talking about the smaller piece, or are you talking about the bigger piece? So we name the major to be the bigger one, and we call the smaller one the minor one. Obviously, if you have equal, well, that's just a semicircle. It's half a circle. So we don't say that. We just say find the area of a semicircle. You don't say half sector. Right? So a sector is portion, and you have a minor portion, you have a major portion. Cool? Let's do an example. That's it for today in terms of theory. Okay, so let's have a look at the first example. Clearly, this is not a full circle. You've got a portion of a circle, and it clearly looks like it's rotated 140 degrees. Okay, and I'm looking for the area of this sector. It's likely to be the minor sector because the other side looks bigger. So the area of this sector, same thing, it's pi r squared. Remember, what does r stand for again? Can I please have, let's go with Jacob. What does r stand for? Radius. Radius is the distance from the center of the circle to anywhere on the edge of a circle. We can see that the center is over here. Here's the center. And the distance from here to any part of the circle, or the curved part of the circle, that's called your radius. So this is a radius. What is the radius equal to? Let's go with Attila. What's the radius of this diagram equal to? 5, very good, because the radius, whether it's from this side to the center, they're all going to be 5 centimeters. They're all the same. Okay? So in the formula, I now know it is pi times 5 squared, because it's radius squared, times, and now the angle that we want out of 360. So this is not a full circle, it's a partial circle. What would the angle be? Let's go with Jacob. 140. Because I only want 140, that's the rotation. So inside I'm rotating 140 degrees and it covers this region, that's 140. On the outside though, if you wanted the area of the other side, you have to figure out the angle for it. So if this is 140, what should the other angle be? What's the other angle to make up 360?
220.
Yeah, 220. Very good. So 220 degrees is on this side. So if they asked you for the other sector or the major sector, we would then use 220. In our case, we're looking for this shape, which is 140 degrees. So you have to determine which of their two angles is going to be the correct angle. Sometimes they'll give you the wrong angle on purpose. Okay, so therefore, you just now say, type on your calculator, I want pi times 5 squared times 140 divided by 360. Grab out your calculator. Let's see if you type it correctly. Remember, 5 squared is not 5 times 2. 5 squared is 5 times 5. Here we go. Let's do it. Pi. Here's pi times 5 squared times, if you can do the fraction template on your calculator, then it will look like this. If you can't do it, you can also type it with a bracket, 140 divided by 360. Same thing. Here we go. Let's see what you get. 3, 2, 1. What? Hands up if you got 30.5432 on your calculator. Good. It means you entered it correctly. Because as small as it sounds, a lot of students get this step wrong. So they do the working out correct and they get this final step wrong. Yeah? So 30.5, what was it again?
5432.
5432. But the question says 1 decimal place. Good. 30.5, and we're not done yet? What am I missing? And that's not how you pronounce it? Squared centimeters. Very good. Next problem. Let's do the same thing. Formula is still pi times radius squared times, and we know it needs to be out of 360. And now be careful here. What's the angle? It's 240. A lot of students will naturally write 120, but what's the problem with 120? 120 talks about this side. See, that is not the side I want. This is where 120 is. And they hinted to you the little angle. See the angles on the outside. I need the angle to be correspondingly curved. So if this is 120, that means this is the angle subtracted from 360 gives you 240. Okay, so it's actually 240, not 120. So you have to look at which area do I want. Do I want the minor sector or the major sector? So it's clearly 240 degrees. What's my radius in this case? Can I please have Charlie? What's the radius for example 1b? 7 meters, very good. Again, center all the way to one part of the circle. This is your radius. This is also your radius as well. So type on your calculator. You're testing out pi times 7 squared times 240 over 360. Let's do it. Here we go. So it should be pi times 7 squared times, oh yeah, with the senior calculators, I can actually just type pi and it'll understand it's pi. So you guys can't do that on your green calculators unless you have the same calculator as me. 240, 360. And here we go. 3, 2, 1. You should get 102.625. Did you get that? Hands up if you got that. Good. Means you're typing on the calculator correctly. Well done. Very good. To 1 decimal place, so it should only be 102.6. Squared meters. Very good. Beautiful. So those are the kind of problems from your fluency skills. That's what you'll likely be practicing. After you've built your fluency skills, usually question 2 to 4, maybe 2 to 5, then you do problem solving. So problem solving then takes that understanding and then mixes a couple of shapes. Let's try a problem solving. Example 2. Let's have a look at example 2. Example 2. Now I've got this shape. I only want this area, the one I'm coloring in blue. That's the region I want. It's not a typical shape, but what we can see is we can see a rectangle and we can also see a quarter of a circle here. So this is a quarter of a circle, and what we can see is if you found out the area of the entire rectangle and then you subtract away the quarter of a circle, it should give you the leftover region you want. So how do you calculate it? Area is equal to rectangle minus a quarter of a circle. And again, why do you know it's a quarter? Because this box here means 90 degrees. And you want 90 out of 360. 90 out of 360 is 1/4. Okay? Let's work it out. Area of a rectangle is length times width minus pi times radius squared times, and we know this is 90 degrees out of 360, which is why it turns out to be a quarter of a circle. Okay? Length times width. Which one's my length? Can I please have Fitzroy? So for the rectangle, which one's the length? 20. Very good. 20 is the longer side, so we say 20 times the shorter side, which is 10. So that will give you the area of the rectangle. So I just put it in brackets so you can see that's the rectangle. Minusing, now you're going to work out the circle. The circle is pi times, now what is my radius? It's hidden. What's the radius for this quarter circle? Hands up if you can see it. What's the radius? Yes, Eknor. It is 10. Now for those who can't see it, I'm going to try to draw it again. If you look at the circle, see this is the curvy part. If I drew the full circle, you see that distance from the center to anywhere on the point of the curve, that point to this point, we know it's 10 because this side is 10. That means this is 10 too. So this side is 10, that side is 10. So from the center to the top, that must be your radius, or from this point to this point is your radius as well. So that must be 10. Okay? And that's the only part that's problem solving. So that's what you have to be able to do to look at this composite shape to see if you can identify some of the key properties of the shapes that you know. So radius is 10. We can see here radius is equal to 10. So then it becomes 10 squared times 90 over 360, which is a quarter. All right, let's type it all in the calculator. So 20 times 10. Here we go, 20. Now notice how I told you. Remember last session? You can do them individually, but be careful, don't round during your calculations, only round at the end. So I personally like to do it all in one step. Okay, I know a lot of students break it up. They do rectangle first, then they do circle, and then they take away. But if you do that, you're more likely to round your answers early. So instead, this is how I would do it. I would literally just do 20 take away times 10. So that's my rectangle. Minus, here's my circle. So it's pi times radius, which is 10 squared. So pi times radius squared times, and I want 90 out of 360. So I want a quarter of a circle. Type it all in one go, and you should get the answer with all the correct decimals. If you rounded each one individually, this part here will change. Okay, so that's where I prefer that you try to practice typing it in one go. Problem with that, not many students are strong with their calculator skills. They don't type it well, that's why this step is wrong. So you practice, use brackets to separate them. I separated the rectangle and circle with brackets. Okay? So if you're not getting 121.4601, you've typed something wrong. With your calculator, here we go. I'm just going to paste it over here. so your answer should be 1.46. So 1, right answer 181.5. So round to 1 decimal place, take first bit after decimal, next bit after, that's 5 more, then you increase this by 1. Okay, that's becomes 1.5. All right. Well, yeah, that's it for today's lesson. There's other problem solving. Have a go. I'll write the solutions up, but I want you to have